So in this video, we're going to evaluate logarithms. I'm just going to call it logs using their properties. Now, the properties are these. The first one is always, or usually, it depends on the book, but any base, if you're taking log base A, any base of 1, it's always 0. And that is 0. Okay, let's try this again. 0, there we go. Now, number 2 is if you have log base A of just A, that's actually 1. So it would be like saying log base 2 of 2, that would be 1. Okay. The third one is one I think we use most, where we have log base A of A to the x. It's actually just x. And it actually, this rule, number 3, is why number 2 is the way it is, because this is really just a to the first, and that's why it's just 1. Now the fourth one's completely different. This is a raised to the log base a of x, but the answer is x. These are sometimes called the inverse properties because of the way inverses break each other down. We learned that in a previous section of coursework. So how do we evaluate logs using their properties? Well, let me put one in, or write one down here. Log base 5 of 125. Now, I know on your calculator, some of you have log base, that's under math, and you can type in log, or see if you have log base. If it's an older calculator, you probably won't. And you can just type it in just like it is. But actually typing it in, it takes more time, especially if you're using the change of base formula, which takes a lot more. Change of base formula is if you have log base A of x. This would be log x over log A. And this, you would use this if you're not going to use log base, but this is very complicated. It's a little bit much. So using the properties means you don't have to use your calculator. This is the same as saying log base A, and 125 can be rewritten to be 5 to the third power. So essentially what's happening is this log base 5 is canceling with this exponential 5. So what is happening is we just get our 3. Now it goes directly to this particular problem here. I'll give you another one. Let's say, let's do log base 4 of 16. And you can figure this out quickly that this would be 2. Now, if you did want to check your work a little bit and type it in, and you're stuck having to do it this long way, you would type it in log of 16 over log of 4. Yeah, of 4. And you'll see that it comes out to be 2. So let's take a look at some that are on this next homework that are a bit tricky, but it's just using this property. So here's our first problem. Let's do the second problem. Log base 4 of log base 3 of 81. And that's all you're given. So if you take a moment and you figure out, you start here, you figure out that 81 is the same as 3 to the 4th, then we know that we've got log base 4 of log base 3 of 3 to the 4th. So these cancel, this log base 3 and the exponential cancels. So we have now log base 4 of 4. Well, by property number 2, we know that that is 1. So this complicated thing using logarithms is just 1. I don't think it's obvious. So it's kind of like a puzzle. So I like puzzles. I don't mind them. we have that. Here's another one. 4 raised to the log base 4 of 7 plus log base 3 of 3 to the negative 2. Okay, this is actually using number 4 in the list of properties here. Property 4. What we see is that this exponential 4 will cancel with log base 4. This log base 3, oh, it does use this property 3 too, cancels with this one. So it's a little wonky, but this is all it is. So our answer here would be 5. So personally, I think that it's faster just to do it than type it in, but your calculator keys are here. You either use the log base under math, or you would type it in long ways like this using the change of base formula. Hope that helps.